Chapter 8 Motion. Already I have given some of the numericals to you. Example 8.1, 8.2, 8.3, 8.4. And page number 110, question number 1 is given. Today I will continue page number 110, question number 2. One more numerical. A bus decreases its speed from 80 km/h to the power minus 1 to 60 km/h to the power minus 1 in 5 seconds. Find the acceleration of the bus. Remember that 1 km/h to the power minus 1 will be 5 by 18 meters second to the power minus 1. Here initial velocity will be u, 80 km/h to the power minus 1. We should change into meter second to the power minus 1. So 80 into 5 by 18 should be multiplied. After cancellation, 200 by 9 meter second to the power minus 1. Final velocity v, 60 km/h to the power minus 1. We should multiply by 5 by 18 to change into meter second to the power minus 1. After cancellation, it becomes 50 by 3 meter second to the power minus 1. Time t is 5 seconds. Acceleration formula, acceleration a equals to v minus u by t. So v, u should be replaced, downside timing. Here LCM should be taken, 9. Upside 150 minus 200, that becomes minus 50. 9 and 5 both are denominator. After cancellation, it becomes minus 10 by 9 and unit should be meter second to the power minus 2. Because when this second will go up, power will be s to the power minus 2 only. After division, your answer is minus 1.11 meter second to the power minus 2. Now, question number 3 in the same page. A train starting from a railway station and moving with a uniform acceleration attains a speed of this much in 10 minutes. Find its acceleration. Since the train is about to start, its initial velocity should be 0. Whenever the body is going to start, initial velocity u should be 0 meter second to the power minus 1. Final velocity v will be 40 km/h to the power minus 1. After cancellation, because we are changing into meter second to the power minus 1, so we should multiply by 5 by 18. After cancellation, it becomes 100 by 9 meter second to the power minus 1. Timing t is given 10 minutes. We should change into second by multiplying 60. It will be 600 second. So acceleration a is equal to v minus u by t. V is 100 by 9, u is 0 and timing is 600. After subtraction, because it has 0 only, so 100 by 9 by 600, 9 should go down. After cancellation, it becomes 1 by 54 meter second to the power minus 1. Then we can make it decimal. It will be 0.0185 meter second to the power minus 2. Page number 114. Some of the questions are there related to graph. Like, what is the nature of the distance time graph for uniform and non-uniform motion of an object? So the nature of the distance time graph for uniform motion will be always straight line, and for non-uniform motion will be always curved line. You have drawn the graph already. Question number 2. What can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? Whenever distance time graph is a straight line parallel to the time axis, at that time the object, a body, will be at rest. What can you say about the motion of an object if its speed time graph is a straight line parallel to the time axis? So when the motion of an object whose speed time graph is a straight line parallel to the time axis, then the object will be moving with uniform speed. And number 4, what is the quantity which is measured by the area occupied below the velocity? Occupied below the velocity. Okay. So question number 4, question something was mistake. So please correct it. What is the quantity which is measured by the area occupied below the velocity time graph? So as you heard that already, graphical concept is given to you. Under velocity time graph, whatever area will be represented, it may be rectangle, maybe trapezium, maybe anything else, but after calculation that area we can find out distance only. That's why answer should be distance. With this, I'm going to conclude today.